All right, so I want to figure out what would be the future value, also known as ending balance. Key phrase, super important phrase here. We are taking this $1,500 and we are depositing it every month. So not only are we earning bank interest here, but we are adding our own money to our account as well. And so when we are doing these regular deposits, that's actually called a periodic deposit. And we have a special formula for that and everything. It is a little bit more complicated than the ones before because we're not only earning money from the bank, but we are also adding to that money ourselves with our own deposits every single month in this case, but they don't always have to be monthly. They can be different time periods. You could do it once a year. You could do it semi-annually, quarterly, weekly, daily if you wanted to. It really just kind of depends on, your own situation and what works for you. And our problems, our examples that we do, will have a variety of examples with that. But this is our formula that we use. Our letters all stand for the same thing in the other formulas that we've done. So no difference there. We just need to be very careful that when we set this up, we use our parentheses correctly. They are all super important here. And I always suggest that when you write this out, or when you go to solve one of these problems, that you actually write it out first, so that you make sure that you don't make any silly mistakes. And I apologize for them kind of running together here on my screen. Hopefully the two different colors helps to differentiate between the formula, the general formula, and then the problem itself. And when we type this into the calculator, you want to make sure that you are being very careful, very precise when you do this. But after 10 years, we are going to have $213,579.73. So a nice little nest egg there. A lot of people do this when they're saving for retirement. But again, the important part here is this deposited monthly, those repeated deposits. Our second example here, we have our interest rate, 9.6% compounded annually. We are investing $12,000 every year for 15 years. But that invested every year, that is our important phrase. And that is what tells us that we have a periodic deposit. And again, it's that repeated deposit or repeatedly adding to our account. And that is what makes it a periodic deposit. And again, the formula, it looks a little bit more complicated than our previous ones, but it uses all the same letters. Because this one is compounded annually or investing once a year and is one. Again, our letters are all the same here as they were in our previous formula, so that's nice for us, so we don't have to learn new letters, but we just need to make sure that we take our time and we are very, very careful about writing this out. And then when we go to calculate it, we need to be very, very careful when we type it into our calculator, as it's very easy to have a typo. It's very easy to make a mistake when typing it in. It happens a lot. So in this case, we would have, after 15 years, $494,388.46. So just under $500,000. Our third example here, again, we need to find that key phrase. So we see $2,000 invested every year. That is our key phrase here. That tells us that this is a periodic deposit. Apologize for the sloppy handwriting. So periodic deposit formula, I have my principal. Make sure you double parentheses. I'm going to try to move quickly. Calculated annually once a year. And this one is for 40 years. Don't forget that -1 there. And that ending balance is going to be 885,185 and 11 cents. So after 40 years, you've got $885,185 and